Guys. So basically, this session we wanted to have Steve with us, who will guide you that what are you going to face, because some of the students, they always come to me and tell me that Naman, I am I'm nervous. I I think I cannot do. A lot of people, they come from non-IT background, getting jobs in IT, and the real example is Steve. And that's what I would like to tell every one of you. It will take some time, but it is not impossible. This is real. Now, coming to our next part of the session, that is on the IT architecture or the AWS architecture. This is one of the very important question which is being asked in all the interviews whenever you go for your cloud interview, whether you are getting interviewed with Amazon, whether you are getting interviewed with any other organization, you will be asked this question about multi-tier architecture. So some people say it multi-tier architecture, or some people say it multi-tier architecture. So over here, basically, when we say architecture, so for the people who come from non-IT background, it's not about the architecture of your home or a building. It's not the architecture about that. It is the architecture about the application. Now, few of you might think that what is architecture? When we have a phone with us, and on a phone, if we open Netflix application, there is there is an application, but where is the architecture? What is the application architecture? This question, everyone has this question when you come into IT very first time, and when you hear this word architecture, you always feel surprised to know that what is this architecture. So if I tell you that I, I was working with Microsoft few years back, and when I was working with Microsoft, I used to work with Outlook.com. So just like we have Gmail.com, Microsoft has Outlook.com. I was part of the Outlook.com Seattle team. And over there, you will be surprised to know that there are more than 80,000 servers which are sitting in the background. When you basically send an email, there are more than 80,000 servers which are in the background. So when we say architecture, it is all about the infrastructure architecture, which means the IT infrastructure architecture, which involves your servers, it involves your load balancers, it involves your database, it involves your cache, like whatever components you might be learning in your classes. It's all about that architecture, that how are you going to combine all the components together and make it a good architecture which is going to support an application. So when you use Netflix, there are hundred of servers which are getting in used, and you never know this because you just see it on one click. Being a user, being an end user, we see everything on one single click. But how the request is getting processed, how the infrastructure architecture is being created behind the scenes, that when you click on watch movie button, the movie pops up and you start watching movie without even downloading it. So there is the efficient IT infrastructure which is sitting in the background. And being a cloud architect or being a cloud engineer, your responsibility is to architect the infrastructure in such a way that it is more efficient, it is robust, and it is taking care of all the things. So when we say infrastructure, it is all about, or it is all about that how different components or how different infrastructure components connect together. So that is what the IT infrastructure or IT architecture is. Now, why do we need to know IT architecture? Okay, we know servers, we know how to create EC2 or virtual machine in the cloud. We know that. Superb. We know how to basically balance the load using elastic load balancer. We can balance the load. We know, okay, in databases, we are going to store data. that is also very clear to us. But why it is important to have a knowledge of architecture in the interview, and why this question has become the most important question of any interview? That is because having architecture knowledge always defines that how much knowledge you have overall. If you know the architecture, it means you know every component. So it is easier for the interviewer to rate you on each and every service if you define the architecture. That is why I was listening to one of the interview some days before, and the very first question, and it was the Amazon interview. You can imagine it was the Amazon interview. And the very first question which was asked in the interview was, how will you define the multi-tier architecture? And I was surprised. I was surprised that none of the interviewer asked about servers. None of the interview asked about the load balancer. None of the interviewer asked about databases. They just asked about the multi-tier architecture. And that was the only question asked in the interview. And there were some following questions as well on the architecture. So you can imagine that how important it is. And that is why we brought this question in this interview preparation session or a webinar, to make sure that you guys are aware. And when you go next time in the interview, you guys are prepared. Now, it defines your experience. Okay, it defines your experience. You might know all the components. Okay, you might know all the components that defines, or how these components connect together, that defines your knowledge. Now, that will be the first question they will ask you. Describe about multi-tier architecture. You will tell about some of the components. You will tell how these components connect together. That will define your knowledge. That, okay, you have the knowledge, you know how to connect different components together. But following questions will define your experience. Okay, like they will ask that if this particular component is not working, how will you make it working? That is what your experience is going to answer. So you will say, okay, I will replace it by something else, or I will do some automation like ASG, auto scaling group, and immediately I will auto scaling group is going to replace the EC2 instance. That defines your experience, that you are aware that how you are going to handle the architecture if it fails, because anything can fail, right? Anything can fail at any moment. So you are going to define your experience by telling the answer on the architecture, and those will be the following answers to the questions asked in the interview. Okay, that is why having the AWS architecture knowledge is must. Now there are multiple architectures. Okay, first one is the multi-tier architecture. Second is, so some people call it as multi-tier architecture, or you can say three-tier architecture. Okay, so three-tier architecture. It like the interviewer can ask you what is multi-tier architecture, or the interviewer can ask you what is three-tier architecture, but it is one and the same thing. So don't worry about it, that what is three-tier architecture. Don't get surprised by hearing three-tier architecture. Multi-tier architecture and three-tier architecture both are same. So don't worry about it. And in today's session, we will discuss about multi-tier or three-tier architecture. After that, there is another architecture which is very popular in the market right now, that is the serverless architecture. And on serverless architecture, we are going to have the webinar next time on serverless architecture, where we will understand that how serverless architecture works, why serverless architecture is considered to be the best, and in what scenario you are going to use serverless architecture. So that is what we will study in future session. And third, then there can be a question which can be asked that will be on microservice based architecture, which is very popular. And few of you who have been attending our live projects, one of the project is on microservice and one of the project is on serverless. So I hope you guys have a good amount of knowledge on serverless and microservice who have already attended our live projects. So these are the two architectures which we will be discussing in next webinars. But in today's session, we will again, I'm just telling it again that we will be talking about multi-tier architecture or three-tier architecture. Now, what is important? What are the components of an application? Let's first understand this, that what, like whenever we use Netflix, right? What are the components which are important for this application? So Netflix is an application, and what are the components of this applications? When I say component, I am talking about IT infrastructure components. Okay, I am talking about IT infrastructure component. I'm not talking about, components of anything else. It's all about infrastructure and application. Always remember, guys, that your entire application is always divided into three parts. Okay, so whether you pick Facebook application or WhatsApp or your Netflix, any application in the world will have three parts. Every day you use Thinkcloudly application, you watch your recorded sessions. So those that particular Thinkcloudly application as well is divided into three main parts. Always remember this. What are the three parts? First one is the front end. Second is the back end. And the last one is the database. Okay. Front end means what a user sees. Okay. So when you open Thinkcloudly, you see button over there, you see some links over there, you see a video. So those are part of the front end. Okay. So front end means a face of your application. So when we say Netflix, right? When we say Netflix application, so Netflix is the application which has the front end, that is the mobile application. In your mobile, you open Netflix, you watch movies, that is front end. Now, all the information is always stored in database. Okay, so let's say that username, my name is Naman Jain, so my name is stored in database. Whichever movie you watch on Netflix, that is stored in the database. Every data you see on a Netflix application, that gets stored in the database. Okay, so database is really very important for any application. Let's imagine that you have Zelle, you use Zelle or Cash App. They have a transaction history. Transaction history is also maintained in database. All the data which you want to sustain, that is always kept inside database. Your recent balance, whatever transaction history you want to see, movies, everything. YouTube has movies, right? So I mean, it has videos. All the videos are always saved inside database. So database always keeps data. Now what happens that when you want to basically link, you want to link the front end. Front end means where people watch movies. Let's imagine this is the Netflix application and you click on watch button. When you click on watch button, immediately a movie plays on your application. You start watching movie. You know how it happens? When you click on this button, a request goes to database, and database basically shows the movie. It pulls out the movie. Now, you must be wondering that when front end is used for the application and database is used for the storing data, then from where this backend comes into this picture? Why do we need backend? Okay. So to make your application robust and to make this application strong, backend is very, very important. Why? Because when you click on the watch button, the request goes to backend. Backend is a translator between front end and database. So it understands, okay, Naman is trying to watch a movie and he wants to watch, he wants to watch, let's imagine, Mission Impossible. So what will happen that this information will go to backend, and backend will basically pull Mission Impossible from database and will send it to front end. And finally, I am able to see my movie. Okay. So backend acts as a translator between front end and database. so that our request doesn't go directly to database, and there is a proper backend translator in between, which basically does all these operations. Having backend is very important because front end can never send the request directly to database. Always remember this, that front end cannot send the request directly to backend to database. So we need the backend in between. Okay. Now, I hope everyone understands that for any application, whether you use WhatsApp, whether you use Facebook, whether you use Thinkcloudly, whether you use Netflix, whether you use any other application in the world, that has three components: front end, back end, and database. Okay. Now, when we say multi-tier architecture, or we say three-tier architecture, the idea is that we need servers for front end, we need servers for backend, and we need servers for database. So how many tiers are there? Tier 1, tier 2, and tier 3. That is why this architecture is known as three-tier architecture. Architecture we are going to discuss in the next slide. Okay. Yeah. So architecture we are going to discuss in the next slide, but essentially you have to understand that any application is made up of three parts: front end, back end, and database. Now, when the application is made up of three parts, all these layers, whether you can call it layer or someone can call it as tier. It's up to you what do you want to call. Okay. Let me spell tier so that you guys can understand what I'm saying. Tier, T-I-E-R. Okay, some people say tire or some people say tier. It depends on the accent you use. So over here, when we say tier 1, tier 2, tier 3, that is why it is known as three-tier architecture or multi-tier architecture. Now see, we have to understand one thing. All these tier cannot run in the air. It cannot run in the air. Okay, it doesn't run in the atmosphere. It runs on servers. Okay, so to run front end, we need servers. Okay, to run backend, we need servers, and to have a database, we need servers. Simple. All these tiers run on a server. Okay, and server, when you have servers, it means you are talking about the infrastructure. Okay, okay, let's imagine there is a patient in the hospital. There is a patient needs to be operated. Okay, needs to be operated. He will be operated in operation theater, that is OT, right? Patient has to be operated in operation theater. Okay, so basically before I was dropped, what I was discussing, that we need these servers to run the applications. Okay, so we have these applications front end. I mean, this is one application, but these are the different components of one single application. So front end is one component, back end is another component, and database is another component. And all these components require dedicated servers to run. Okay, so you have the website runs on some server. There's a backend application which runs on the server, and the database, it always runs on a server. Okay, so now when we basically so I hope everyone understands that servers are very important for each components. That is what essentially I wanted to pass on to you guys, that for every stage or every tier, servers are very important. Why I'm emphasizing this, just to make sure that you guys do not forget in your interview. Okay, now let's imagine there is a home. Okay, we are trying to architect a home. Okay, so we want a room over here, we want a room over here, we want multi-story. I mean, we are designing the home, let's imagine, and we need three rooms. We need one bathroom over here, we need one dining hall over here. We are designing a home. When we design a home, first thing which we always take care of is the safety. Okay, that We have a proper doors which has proper locks. Okay, so we always take care of safety. Second, we always want our home to be quack proof. Like it should be a strong house, right? It should follow all the measure to prevent, any effect from from earthquake. So you want your home to be strong. Okay, so whenever you design, or whenever someone architect architect a home, we always make sure that there should be a proper safety, and our house is a strong house. It can take care of storm or any natural calamity. It can take care of it. After that, we ensure that there is proper maintenance. Okay, there is proper maintenance which can be done, right? Now, whenever we create an architecture whenever we create an architecture, okay, of an application, now we need the components. Let's say we need one server for front end, another server for back end, another server for database. Let's imagine we have 3 servers for each server for each tier. So for front end, we have the server. For back end, we have the server. For database, we have the server. And all these 3 are connected together. Okay. Now, even in the IT application infrastructure, the way we think about our home, we always think about this architecture. Why? Because we want our application to be very strong. Okay, so first step is we take care of security. Okay, security is very important. So once a hacker gets into it, everything is gone. So security is very important. Otherwise, hacker can hack your database and all the data will be lost. Security is very important. Security is important for a home. For IT architecture, security is very important. We always understand that without security, our architecture is nothing. Second, we want that there should be an option of auto healing. Okay, so that's the auto healing option makes our IT architecture stronger. Okay, so over here we want our home to be strong, and we will use material which will make sure that our house always stand in all the natural calamity. Just like that, in the IT architecture or IT application, we want it to be strong. And for strong, we have some ways for auto healing, that it can auto heal the architecture. In case of any failure, it can immediately auto heal it. Okay. Third, maintenance. Maintenance is very important. Over here, we want zero maintenance. Zero maintenance means that it can take care of the infrastructure automatically with the help of auto healing, auto scaling, whatever it is, but we want zero maintenance. So these are the few points which should be addressed by our architecture, and that's what make us the good solution architect or cloud architect. If our architecture can address all these 3 points, I am a good architect. So this is what we want to learn over here, that we have to make sure security is playing a very important role to make sure our data is safe, our application is safe, and our infrastructure is safe. Strong, we make it so strong that in case of any failure, because you know that in your home, any appliance can fail anytime. Any electronic appliance can fail anytime. Just like that, IT infrastructure is the electronic machines. It can fail anytime, but there are ways for auto healing that makes it strong. After that, we do not want any maintenance. We do not want to spend on any maintenance. And that's what the cloud comes in. Cloud makes it auto healing proper, it makes it, it gives more security. It makes sure that auto healing option we have, we make sure that we have zero maintenance. Everything is taken care by Amazon. This is what we have to address by our architecture. I hope everyone is with me and able to follow me. Now, how will these points will address? Okay, will get addressed. So One thing we know, if we talk about now AWS, that when we design an architecture in AWS, okay, we want to design the architecture, application infrastructure architecture. If we want to design in AWS, what are the components or services important? That is what we will discuss right now. As you know that there are three parts of any application. Can anyone tell me in the chat real quick? Can anyone quickly type what are the three components of any application which we discussed? Can anyone please tell me quickly? You guys can
Front
type in the chat quickly.
end, back end, and database.
Awesome. So we have the front end, we have the back end, and we have the database. All right. Now we understood one fact that for each and every stage we need the servers. Okay. Now, when we are talking about AWS, and you guys might know this, that we need these servers. So for servers, which service we use? We use EC2. EC2 helps us to create the servers. I hope everyone knows this. People who are joining us new, they might not know it, or the people who are with us and they have not yet joined us. So EC2 is the service which is going to help you to create the servers. So first thing we have addressed that we have our servers with us. Now second we want security. So basically security comes with the help of VPC. I know some of you might be listening this word VPC very first time, but VPC is the virtual private cloud, which increases security, which gives the isolation to our architecture, to our infrastructure. If we want to give the isolation, we'd give with the help of VPC service. For few of you, this might be new service, but I am telling you right now, you can imagine that if we want to, if we have a home and we want to lock this home, we need a lock, right? For any IT infrastructure, VPC acts as a lock. It basically protects our IT infrastructure from getting hacked. So VPC is important to create the isolation, for our, it's like a shield. You might have seen the movie Avengers movie where there was a shield. So VPC acts as a shield. It basically creates a shield around EC2 so that your EC2 servers, where your front end, back end, and database are running, that is safe. Okay, let's look at it quickly so that you guys can understand visually. So over here you see this VPC. So VPC is actually acting as a shield. You see over here, it is acting as a shield. You see this outer circle, it is acting as a shield, outer rectangle box. And inside it, we have EC2s. See, we have EC2s. We are keeping EC2s in a proper isolation with the help of VPC. Okay. Now, so we know that we need servers. Servers are addressed by EC2. So we have EC2s here. You see this EC2, 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 EC2. So we have servers over here. Second, we need security. From where will we get the security? We will get the security with the help of VPC. Now VPC acts as the outer shield. Okay, it acts as an outer layer. But what we have to do to protect inside? To protect inside, we create subnets. Subnet acts as an inner shield. Okay, subnet acts as a inner shield. You see this? Every EC2 is actually inside this subnet. So all these three EC2s are in one subnet, and these three EC2s are in one subnet. So we are basically protecting these EC2 again by creating another layer inside VPC, and that is subnet. Okay, I hope it is easy to understand. So we have our outer shield that is acting as that is known as VPC, and we have inner shield which are known as subnet, and that we are basically making it subnet so that it is acting as an inner shield, so that if anyone gets into VPC, that's okay, but he might not be able to get into subnet. Okay, so that's why we create this subnets, subnetworks. So how we divide the VPC, we divide the VPC with the help of subnetworks. Subnet stands for subnetwork. Okay. Now, so we understand EC2, we understand VPC, and we understand these security with the help of VPC and subnets. Now, we have three layers: front end, as you guys said, front end, back end, and database. If you look at the architecture, our front end is kept on these two servers. Our backend is kept on these two servers, and our database is kept on these two servers. Can you see? I think you guys are getting closer to this diagram now. It is making more sense. When you might have seen it very first time, it might have frightened you. But right now you have started understanding this diagram, that the outer box is VPC, which is acting as outer shield. Inner shield is acting as a subnet. And now we have, in the inner shield, we have kept EC2s. Okay. Now, when we look at these EC2s, right? So these two EC2 we keep for front end. This layer of EC2 we keep it for backend, and last layer we keep it for database. Now there is a question which I'm expecting from all of you. Probably you guys have it in your head right now. Why do we have two servers for each layer? Front end has two servers, right? 1, 2. Backend has two servers, 1, 2. And database has two servers, 1, 2. You know what? IT is vulnerable if there is no backup. There should be always plan A and plan B. There should be a backup. Of everything, you need a backup. So what you do, you deploy these EC2 instances in availability zone, maybe A. And you do, what is availability zone, guys? You might have studied. Availability zone is data center. So this data center is, maybe let's imagine this is in North Virginia, okay, somewhere in North Virginia, and this is again in North Virginia, but another part of North Virginia. North Virginia is a bigger one, right? Maybe these two data centers are 100 kilometers away. Okay, so what are we doing over here? That we are keeping the front end one server for backend, one server for database into one data center, and we are keeping another layer of servers into another data center, which might be 100 kilometers away or 300 kilometers away, but we are keeping it a backup. Why? Because in case of any natural calamity, there is a war, or there's a natural calamity like earthquake, storm, hurricane, a lot of disaster can occur, right? What if the entire data center goes down? It goes down, everything has gone down. Let's imagine Ukraine right now. Let's imagine this one is in Ukraine and Russia has attacked Ukraine. So complete Ukraine, and there is no data center which will be working right now because that is the war zone. So this data center has gone. Now, if my application is running, will I be able to do the business? If I am dependent on one data center only, my business will be affected. That is why we always keep a backup plan. We always keep our servers into at least two locations, because if one location is affected, then we have other location up and running and taking care of all the traffic coming in. Okay, so that's why this is data center 1 and this is data center 2. And that's why you see for front end there are two servers, for back end there are two servers, for database we have two servers. Now see what happens, that if I'm not sure if you guys know this, when you have two servers, right, when you send a request, when you open a Thinkcloudly is running on these two servers. Okay, Thinkcloudly is running on these two servers. It will be too confusing that where the request will go, either to this server or to this server. It's not possible. For that reason, what we do, we place application load balancer in between. What it does, it randomly distributes the traffic. Let's say if Wemo is sending the request, his request is coming in and going here. If I am sending the request, my request is going here. Okay, so this load balancer is balancing the load because every day it might be receiving 1 million requests. You cannot overload this with 1 million and this server is sitting idle with 0 requests. No, this is very unfair. So what this load balancer does, it basically distribute maybe 500,000 requests over here and 500,000 requests over here. So it basically distributes the traffic evenly with both the EC2 instances. So that is the work for load balancer. Now, there is another load balancer you will find over here. Now you can ask me that, Naman, why are we keeping 2 load balancer? And my answer will be that, again, if front end is trying to contact backend, it will send all the requests to same backend. How does it know that half of the requests can go here? So what will happen? We will link these 2 front-end servers with application load balancer again. And this load balancer, what it will do? It will divide the request into these 2 backend servers. So that 50% of the load this will take and 50% of the load this will take. That's why when the request is actually coming and hitting it, we have the load balancer in place so that it can distribute the traffic. Again, when front end wants to talk to backend, it is again hitting the application load balancer and it is going here and here. So what is happening? At every stage, you are balancing the load. Now you can ask me that, Naman, why don't we have the load balancer over here? Because at the third layer as well, we might need the load balancer. So why don't we have? Because backend talks to database directly. Okay, so backend talks to database directly. We don't send the request to another database. We send the request directly to database. Okay, so now you understand what this VPC does. It creates the outer shield. You understand that what this subnets does. They basically create an inner shield. You understand that what these servers are doing. So this is keeping the front end code. This is keeping the backend code, and this is keeping the data. Okay, you understand these layers. You also understand what this application load balancer is doing. Application, whatever request which is coming inside this application, this is getting distributed into these 2 servers. After that, from here, the request will go to another application load balancer so that furthermore it can be distributed. Okay, and after that, it will basically talk to database directly in the same zone. Now over here, we have this arrow. Why do we have this arrow? Because if, let's say, a data is printed over here, we maintain the same copy of data over here. So we do the regular backup. This is called as sync. We keep both the databases into sync so that both databases will have the same data. We want to keep the same data. Okay, because user can come from here or user can come from here. User should see same data. It should never happen that on Zelle, when you're checking your balance, you are seeing the different balance. It never happens. So your data should be here, same data over here, and same data you have to keep here. What will happen? This will make sure that your databases are in sync and balances whatever data you have that matches. Okay. Now there is something we have again, the auto scaling group over here. If you see these 2 components, we have auto scaling group. Now what happens that, as I told you, that these are the electronic machines and anything can happen to anything anytime. I mean, anything can go wrong with the server. Let's say this server dies. So it's impossible for me to identify that server has gone down and I have to go and create a new server. It is very impossible for me because in a runtime, in a real environment, it is very difficult for me to do the configuration again and bring it up. Auto scaling group will monitor these 2 servers. This particular auto scaling group, which is front-end auto scaling group, will keep a check on these 2 servers. If any one of the server goes down, it will immediately create a new one. So auto scaling group is important. Over here as well, when you have EC2, we have a backend auto scaling group. If this server goes down, auto scaling group will identify, oh, this server has gone down. It will again create another one. and this auto scaling group will get another one. So this is called as multi-tier architecture. Why? Because you have, what are the components you have? You have EC2, where you're keeping your front end, back end, and database. Second, you have the load balancer. Why do you have load balancer? Because multiple servers are involved at multiple layer. So over here at this layer, 2 servers are involved. At this layer, 2 servers are involved. You want a proper load balancing. Okay, whatever request is being transferred, you want proper load balancing. That's why we have a load balancer. Third, we have an auto scaling group. Why do we have auto scaling group? Because manually it is impossible for us to monitor all the servers 24/7. So what auto scaling group will do? Auto scaling group will identify if anything goes wrong, it will immediately replace it with the new server. So that's why we need auto scaling group, and auto scaling group is the reason for auto healing. When I was mentioning about auto healing, it was about auto scaling group. After that, we have the VPC, which is acting as the outer shield. And then we have the inner shield, that is the subnets. Okay. Then after that, we discussed that we have 2 data center, 1 data center and another data center. Why? Because if anything happens to this data center, we still have our application turned on this data center. So for backup, we keep we deploy the multi-tier architecture on 2 different data centers, so that if something goes wrong, we have the backup of it. So that's why we have 2 availability zones deployment. And this deployment is also known as multi-AZ deployment. Why? Because there are more than 1 availability zone is involved. And what is availability zone? Availability zone is nothing but the data center. So that's why, because 2 availability zones are involved, that is why we call it as multi-AZ deployment. Okay. After that, so we understand the basic nuts and bolts. Let's look at some of the more security we see in this diagram. If you see, this is public subnet, this is public subnet, and this is private subnet, and this is private subnet. If you understand, this private subnet is actually from here to here. I mean, we are keeping these 3 servers into private and these 3 servers into private. And these are public. Public means anyone can access it. From internet, anyone can access it. Private means from internet, no one can access it. This is the extra security we are creating with the help of private subnet. From internet, directly, it is not accessible. How will we access it? From internet, first we will go here. And if this allows, we go into this. That's why we need Bastion host and Net Gateway. Net Gateway and Bastion host, what they do, they basically allow the traffic to go inside private subnet. Okay. So this is very important. This public subnet we keep over here to ensure whatever traffic is coming inside, it passes through this. Otherwise, we cannot expose the whole application to entire world. Anyone can hack it. Anyone can hack it. That's why we keep our important layers, front end, back end, and database into private subnet, which makes it private so that no one can access it from internet. And why do we need this particular layer? We need this particular layer because the traffic which is coming from outside will be validated and then it will be allowed inside in the private subnet. So this is the extra hop we add just to make sure that our traffic is getting passed on and filtered over here itself. So that is why we create another hop over here. This is the part of the security. And if you guys, I hope you guys are going to learn it in future. Okay. So this is what I wanted to discuss. I hope you understand all the nuts and bolts of this particular diagram. If you guys have covered VPC, this architecture will make more sense. If you are going to, discuss with your instructor about VPC, then after your VPC concept, look at this diagram again. I am sure that this diagram will make more sense to you. And I tried my best to make sure that you understand each and every nut and bolt. We will be sharing the recorded session with you. Watch it again, come back with questions. We will appreciate all your questions you're going to ask. I'm just gonna give, I know it's like we are just ending the session. Just give me one moment. I would like to introduce are different services we offer, because at Thinkcloudly, basically we are trying to become single stop shop where you will find all the IT interview requirement. People come to us, they ask us whether we can help with their interview questions or not, whether we can help with their projects or not, which interviewer asks them to create. So we are the single stop shop if you need any assistance regarding your interview, because these days interviewer assigns the assignment, that complete this assignment, then come to the interview. So you can take our help. We are here to ensure that you get all the required help for to pass the interview. And that's what we create the difference in the market, that we are close to you guys. Okay, Think Loudly is close to you guys. We are not just selling and forgetting you guys. I still remember all the names I have interacted, and I am in touch with a lot of you people. So that's what we are trying to do over here. We provide trainings, resume assistance, interview question consultations, and much more. Um, and other services we offer, live projects. Earlier we used to have like 6 live projects. We have increased the projects so that you guys get more exposure to all the services we offer. Then certification assistance, you need help with the certification, we can work with the vendor team, you guys can interact with them and get it done. Then we help with the resume preparation, interview preparation sessions. We help with the job support, you know. And I would like to give everyone one opportunity to earn $100. You guys can easily make $100 by referring your friend. So refer one friend, make $100. I promise you will get $100. So make sure you guys refer and bring more people. We are trying our best that we spread the word, we go and meet a lot of people, but your help is going to be very helpful for us. That if you refer one friend, that will help Think Loudly to grow and prepare more live projects. Make sure we have a very good content, we have good content writers. So it will really help us if you guys can help to bring a lot of students for us, or maybe one student at least. We help with Azure, DevOps, Cloud, Scrum Master, ServiceNow. These are the offerings we have. Scrum Master ServiceNow is part of the managed IT management, and all AWS, Azure, DevOps, Google Cloud are part of IT technical courses. Okay. After that, like, I'm open for any question, guys. Like, if anyone would like to ask any question, please unmute and feel free to ask your question before we end the session for today. But I really appreciate for your presence. Really, it really means to us that you guys have come and joined us. But now the floor is for you. You guys can ask any question. Yeah, not about my personal life. It's just about this topic. Anything, anyone? Samuel.
Yeah. So I'm just my own, to my own understanding, see if we're on the same page. Um, can you go back to the charts,
Oh yeah.
the VPC charts thing? All right. So to my own understanding, I believe the what you're trying to say in a nutshell, like when you say when you're talking about the public subnets and the private subnets, you can actually be a public subnet in some cases. Like take for example the Netflix app. Everybody can, access, like type in netflix.com on the website, on the web page, and it's gonna bring out the front end of the Netflix app. But you need an account. You need to subscribe. And if you're subscribing an account, that's like subnets right there, securing the app from public. That means like permission and policies is attached to it already. So you need to do some certain things to pass through the private right?
Yeah.
Is what I'm saying related to this whole chart.
No, see, Samuel, it's not about subscription. Okay, it's subscription is the internal functionality of an application. Forget about subscription.
All right, so I'm just trying to relate it to
Yeah, I'm trying.
something.
Let me explain you. Let's imagine that the application front end is here, Netflix front end is here, Netflix backend is here, and Netflix database is here. You would never keep front end. It's not about subscription. You never keep Netflix front end, here. You never keep. Why? Even if you are a subscribed user or if you are not a subscribed user, you still have to first come to public subnet, and then from public subnet, automatically your request goes to this. You think that Netflix is a public application, but internally when we say IT infrastructure, very first the request goes to public subnet, and public subnet validates the request, and then it sends the request to Netflix. It doesn't matter why it is being restricted, because what happens sometimes that it's not about application, it's about, let's say there is a hacker, and this hacker wants to delete the Netflix application. Okay, just think from a backdoor. This hacker wants to delete this application. If we expose this server in public, he can access the public server and delete the application. But what we want a layer again. So over here, hacker will come and he will not be able to go here. Why? Because he doesn't have proper access. So having subscription is the internal functionality of application that is nothing to do with it. That's the front end part of it, that you can go inside the application. But I am saying, think from a server perspective. Now you have a laptop. Who can log in into your laptop? Who knows the password? So just like that, if we keep this particular server over here in public, which has the Netflix front-end application, hacker will come and log into the server and delete this. So you have to understand it, that it's about from a backend perspective, think about a server perspective. Don't think from an application perspective. Application just gives you a login form. Okay. Just forget about this login form. Login form is part of front end. Think about the server-based application, server, that someone can delete the server. You will not have your application at all. It's not about login, it's about server. I hope it makes sense. Otherwise, I'll clarify it later point of time. Yeah.
Yeah, it does.
Okay.
It does now.
Awesome. Thank you, Samuel. Anyone else having any question which I can answer?
Yes.
Hi, Yusuf. How are you? Is that Yusuf?
Yeah, please, can you go back to that illustration?
Yeah, please. Yusuf, please speak a little louder. I cannot hear you.
I'm sorry, I'm in a very far place, so I have to use the public internet.
No, Yusuf, kindly speak a little louder. I cannot hear you.
Okay, I will try as much as possible.
Yeah.
Can you hear me now?
Yeah, much better.
Yeah, when you were illustrating the IT component parts, the three parts, you said the purpose of the database is to interface between the front end and the back end.
No. I said backend is the interface between front end and database.
Back end is the interface between the front end
and database.
So, but while you are then the application load shedding and the auto scaling, I can see that. Okay, I got you now. Okay.
Awesome.
Thank you.
Hey, hi, Chinonso. Is this Chinonso?
Yeah. So can you just throw more light, shed more light on how you can connect from the public to the private servers? You know, already when you already have both on the VPC, just throw more light on how to connect from the public to the private, please.
Let's imagine that you are a developer, or you are let's imagine you are the cloud engineer.
Name of the type.
Okay. Yeah, you are the. Can you mute, Gaurav? Can you mute everyone, please? Except me, please. Yeah. Let's imagine, so that you're working as cloud engineer, and when you work as cloud engineer, you have to make some changes to this server. because you are allowed to do it and you want to make this changes to the server. As these servers are in the private subnet, you cannot reach these servers directly. It is impossible because these servers are part of isolation. You cannot reach them directly. How will you reach them? First, you will log into these servers. Okay, you will connect to these servers, and from here, you will jump onto this server. This is how you log in. You cannot log in directly. That is not possible. First, you have to log into this, and then you go here. Okay, so it is about connecting. How you connect to a server. There is a way of connecting using PuTTY. You connect to a server, right? Using RDP, remote desktop. There are applications. So with the help of PuTTY, first you will go to this Bayesian host, and then you will go to this server, either this one or this one or this one. If you want to go here or if you want to go here, you are allowed, because private subnet is accessible by the public subnet only. If someone tries to go directly here, that is not at all possible. Okay, it is about if you want to log in as a cloud engineer, that's why you create this security. Does this make sense, Chinonso?
So my question is, why don't we have the public subnets? Why don't we have the public outside the VPC? Like maybe if we want to connect, we might go through the route of using NATs or something thereabout. So that's my question, though.
No. Public subnet cannot be outside VPC, because public subnet. See, what is subnet? Subnet is subnetwork. Okay, subnet is subnetwork. What does it mean? When you have a VPC, subnetwork divides the subnet. You call it public this one and you call private this one.
Okay.
How will you basically create public subnet outside VPC? It is impossible to do it.
Yeah.
Technically, it is not possible. Public subnet is always inside VPC. Now you can ask me that when public subnet can be accessible by outside, right? Why are we not keeping it outside? Why technically we don't keep it outside? Because this is the layer of security. This is one layer of security, and this is another layer of security. You pass one layer, then you go inside another layer. So you have to pass this one layer. Make sense?
Yes.
Yeah. Anyone else?
Yeah. Question from for the VPC. What are made of the VPC securities?
Sorry? What are the?
For the VPC, what are the component like? What was it made of the VPC security? What are made of them?
Nothing, but you basically give a private IP address range to a VPC. So you define that only these IPs will be part of it, and that defines the VPC.
So how do you connect into the VPC?
How do we connect to the VPC? VPC is directly accessible. Okay, VPC is directly accessible. You do not need to do anything else to connect with VPC. When you say public, it is already exposed to internet. Okay, so on public we expose these servers to basically to the internet, so that you can easily directly go inside it with the help of IP address. You can go inside it. Okay, but you cannot go inside private subnets without logging here. This is a hop. So if you want to go to, let's say if you are traveling from Africa to, let's say New York, okay, there might be a hop on Mexico, okay? Or let's say if you are traveling from India to New York, there is always a hop in Dubai, and then you go to New York, right? So private subnet is actually a hop, so that you do not directly enter into private subnet and mess it around. Okay, and there are other concepts which you will be learning, that there are concepts like network firewalls. So there is a NACL as network access control list for public subnet. Maybe you will come into this, but after that you will be blocked, because every subnet has its own NACL. So at every place you will find a firewall. Over here, firewall. So when you try to enter, maybe you will enter into public subnet, but you will not be able to enter private subnet. So that's a part of security.
Okay, what you just explained now, the network access control is, that's what I wanted to understand. Thank you for that.
Okay, awesome. Oh, sure, Johnson. Okay. I hope we are good because we are already 30 minutes up our time. Guys, feel free to basically connect with us anytime. Refer your friend. I really request everyone. In return, if you can give us anything, that is just referring your friend and bring it to us. That's the humble request from everyone. And if you have anything else to be discussed, you have any question, anything, feel free to drop your questions to us on our official contact number. I hope you everyone have it, or you can touch base with your instructor, and that is also what you can do. And thank you so much for coming to this session. Really appreciate your time, and I hope you guys enjoyed this session. If you and we will make sure that we have these sessions regularly. Every second Saturday we are planning right now. In future we might have it every Saturday, but we don't know right now. But every second Saturday we have a plan. We will be meeting now, uh, you know, next to next Saturday, and we will be discussing something new, which is really going to make you interview ready. That's our goal. Thank you, everyone. Thanks for coming to this. Really
Thank
appreciate
you.
it. Thank you. Have a good one.
Thank you.
Please upload the video, please.
Sure, sure. We'll send the link to you guys. Yep.
Thank you.
Thank you, everyone.
Hello, is it the link that you're going to send, or it's going to be on the page? I mean, how do we access it?
You will, I mean, we will upload it on YouTube, and we will share the YouTube link with all of you.
Oh, you're going to upload on YouTube. Okay, I was thinking it's going to be on the homepage, like.
Yeah,
on
that's-
this.
Yeah, we will upload it on dashboard also. Don't worry.
All right,
Okay.
thank you.
On dashboard. Okay.
You will find all the webinars.
All right. Thank you.
Old session. Yeah, thank you. All the webinars, all the old webinars also on your dashboard very soon. Okay.
Okay, sounds good. Thank you.
Thanks. Thanks, everyone.